Okay, so welcome everyone to the second day of DSE2022 in Australia. It's wonderful to have you all here. My name is John Stahersky and I'm going to be chairing the first session. So in this first session, we have a very distinguished lineup of economists. And the first of our speakers is Ariel Pakes from Harvard University. So we're delighted to have him here in Australia and really looking forward to his talk. Thanks, Ariel.
Thanks for having me. I think the younger members of the audience should realize how much work it takes to put all this together. And the whole group of DSE Council or whatever it is have been doing this for a number of years, and they're sort of keeping dynamic structural models alive. So it's very nice and I appreciate it. This is a joint paper with Pierre Dubois from Toulouse. It's the first time I ever presented it, and it's not all complete, and you'll see where I'm going. This doesn't work, does work. Pardon? Click once. Oh, this, you want me to use this? Oh, okay, I can do that. I can do that.
That's fine. It was just because the screen was not activated.
I see. Okay. So the paper is about direct-to-consumer advertising and pharmaceuticals. So pharmaceutical market in the US is the biggest in the world. There's about $500 billion in revenue every year, sorry. My data is going to be quarterly, okay? There are two types of promotional spending or advertising. One is detailing. It's about $11 to $13 billion per year in my years. And it's usually when they send representatives to doctors is the biggest cost of that and explain the nature of the drug to doctors. The other is direct-to-consumer advertising. These are all prescription pharmaceuticals, okay? Direct-to-consumer advertising, it's largely done on TV, and it's about $4 to $5 billion a year industry. So there's only two countries in the world that allow direct-to-consumer advertising. One is the United, at least among the developed countries. I haven't looked at the underdeveloped countries. One is the US and the other is New Zealand. And detailing is also much more restricted everywhere else in the United States. Okay? So I'm going to ask questions about whether that's the right thing to do or not the right thing to do. Okay? I'm going to analyze four markets. Or in the end, we will end up analyzing four markets. I won't have everything ready for you today. Drugs for asthma, cholesterol, depression, and ulcer. They're about a quarter of the whole market for the quarter of whole expenditures for direct-to-consumer advertising, a little bit less for detailing. Okay. Not all drugs are advertised. About 50% of the drugs in our sample are advertised. I'm going to focus on DTC. About 50% do DTC, and about do detailing. I'm sorry, and about 10% do DTC. Okay. However, the guys who do DTC have, as large or larger a quarterly expenditure as the guys who do detailing. Okay, so the expenditure per period is about the same. It's a little bit larger for DTC. Okay, so why do people not allow DTC? Countries not. The argument is that in most of these industries, the drugs are really very compatible with each other. And the investment incentive is really a business stealing incentive, which has no net benefit to society. Okay. There's also a little bit of a worry against misinformation in the incentives for doing this. The argument that the pharmaceutical companies make is what DTC does is it makes consumers aware that they can get a drug for whatever is ailing them, and they can do it before the ailment gets very serious. Okay, so that's the argument from the pharmaceutical thing. So the question that we're going to try and analyze in this paper is how useful is the advertising, and is there more socially efficient ways to organize it? Okay. So it's a complicated market. There are 30 to 50 products in each market. There's no way either I, as a researcher, or the firms as actors can actually compute a full information Markov perfect equilibrium. They don't have all the information. That's the first thing. Okay, and even if they did, they couldn't compute it. No supercomputer could compute this in 7 years. You know, it's that kind of problem. So I'm going to use a different equilibrium concept than you guys maybe are used to. It's called experience-based equilibrium. It was introduced a little while ago by co-author Chaim Frischman and I, and here's how it goes. Firms choose policies to maximize their perceptions of the expected discounted values of future net cash flow, conditional on what they know, okay? So they are trying to maximize. Their expectations need not be correct, okay? Perceptions are consistent. The equilibrium concept says, perceptions are consistent with outcomes at states that are visited repeatedly, but not at other states. So not off the equilibrium path, if you like, okay? So the implementation empirical work, excuse me, I'm going to use data to determine what observables the firms and advertising respond to. And then I'm going to allow for a serially correlated state variable, okay, which the firms observe, okay, and is serially correlated, but I, the researcher, do not, okay? And that's to pick up the impact of everything that, that the firms use in their decisions, but it's not in my data, okay? Good. The properties of equilibrium, it's going to allow for asymmetric information. Firms can use different things, okay? And the rationale for consistent perception is pretty obvious, which is if I hit a point repeatedly, I can find out the empirical distribution of those states. And you can do the paper in the QJE does this formally, okay? So what I'm going to do is I'm going to do empirical work, and that's going to generate the parameters that are invariant to the equilibrium distribution, okay? Like marginal costs, setup costs, stuff like that, okay? Then I'm going to give you a computational algorithm that computes equilibrium policies of the experience-based nature. And it's going to do it for a continuous state space with continuous controls. Okay. Then I'm going to compare the equilibrium policies that I get, both to the data, okay, and to the equilibrium policies I calculate when there's no DTC allowed. Okay. So they're two different sets of policies. Okay. You know, we're going to go further. In the end, what we want to do is we want to look at what would happen if we taxed advertising, we taxed revenues, and then had a central body that did advertising for the drug. Okay, the central body could say, if you're sick, you have GERD, or, you know, before you can go to your doctor. And if you don't go to your doctor, you're going to get ulcers. Okay, but you can't say a brand name. Okay, okay, so let me give you the steps in the analysis. I need a demand system because that's where the incentives are. So I'm using BLP. I won't go through this. I'm hoping people understand it. Then I'm going to estimate a controlled Markov process. So I'm going to do BLP, get out the quality term, which we call XC all the time. Okay, and then I'm going to do a Markov process on XC, okay, where it's controlled by the advertising. So the more advertising I do, okay, the better my stochastic distribution of XC next period. Okay, and it follows, so it's a stochastic model of investment. That's enough to compute business stealing effects because I can shut down one of the person's advertising and see what would have happened to that person's revenue, okay? But to go further, I need the theory, the estimation, and the computational algorithm, so I'm going to do that. And I'll do it rather quickly. You can't get all the equations in 50 minutes, no matter who you are. Even if you were Ken Arrow, you couldn't do it. And so what's ready for today is mostly just anti-cholesterol, okay, and not all the, I will give you the no DTC. We worked very hard to get the no DTC counterfactual done for one thing before today, okay, so that was, okay. So this is just BLP. It's a pretty loaded model. Every molecule has a fixed effect. There are random coefficients on all the price coefficients. There are other controls like time. So if you look at the estimates, you know, there's between 20 and 200 right-hand side variables that are here because depending on the amount of molecules, ATCs is a classification that the medical uses for type of molecule. This is Pierre's way of doing it. So 3 stars mean it's significant at 0.001. Okay, 2 stars means it's 1% significant, and 1 star means it's 5% significant. So you can see the results are coming out pretty strongly. Okay, I'm not going to go over the numbers too much. Okay. This is the distribution of the error term. It's a kernel estimate with a data dependent H. And so you can see it looks pretty normal, the distribution of the errors for the 4 industries. And so I'm going to use that later on. Okay. So the second thing I need is the distribution, the Markov process for the quality term in the demand system. Okay. So it's going to be, I wonder if this really works. Does it? Sort of. No, it doesn't. Okay, it's okay. Oh, there it is. Right. There it is. Okay. So I don't know what just happened, but okay. That's a good thing. Oh. Sorry, guys. So CT, you can probably hear my voice. CT evolves as a Markov process. So it's a function of CT minus 1 and the advertising. And we differentiate between the two kinds of advertising. Is this on now? Okay. We differentiate between the two kinds of advertising. In addition, we put in other variables and that they're going to be determined by the empirical work. This is what we started with down here, but it works out that the cross product of the two don't matter. And for most of the industry, no, not the one I'm going to focus on, which is anti-cholesterol, beta AD, the detailing and the DTC coefficients can be made equal. Okay, that's not true in the industry I'm going to go. So we've done a lot of testing on this. We let rho, the serial correlation coefficient, depend on different for generics and patented alternatives. We asked if there were dummy variables. There's dummy variables in the demand system. Okay, so this is just asking, does the effect of advertising change over time given the demand system? And it doesn't, and so on. Okay, so I can show you these are the estimates from this for the Markov process. So the thing to note is that the serial correlation coefficient is huge, okay, which you might have expected. And detailing and DTC, at least in anti-cholesterol, both are very highly significant. And the other ones, you have to put them together before they're really significant. Okay? You don't need to remember this, just the general character of the results. Yeah, go ahead, Ashley.
Is there a market expansion? I mean, there is a market expansion effect because the omitted category.
Yeah, there is market expansion. We built it in. It's in the, when you do BLP, there's an MT term, right?
Yeah. That's going to get pulled through. If I advertise, can I increase your volume?
Yes. Okay. You're going to see this in a second. Okay. Okay. So with just the demand system and the Markov process, I can ask, what would be the business stealing effect? And how would I ask that? I would say, look, you shut down your advertising, but everybody else keep their advertising. How much money would I lose? Okay. Here's the answers. They're huge amount of money. I'm just going to look at the DTC numbers. It's, between 50 and 25% of their revenue per quarter. Okay, those are big numbers. Okay. Okay. So we know that there is a big business stealing effect. It still doesn't say that we want to get rid of DTC. Okay. I'm now going to give you a model. To go further, I need to compute an equilibrium without DTC. So I need a model to do that. Okay. So the WA here is just the expected discount, the agent's expected discounted value of future net cash flow, should the agent choose a particular value of A, conditional on what the agent knows when he makes that choice. And what the agent knows is this CIT, which is the thing from the demand system, okay, and some information set, okay. So how am I going to treat the information set? What I'm going to say is, look, I'm going to use my data and explore which observables affect it. And then I'm going to allow for an unobservable state variable that's serially correlated, and we'll find out whether it's serially correlated or not. Okay, so the state variables will be the observables, and this unobservable is supposed to pick up the impact of everything that I'm not seeing. Okay, so I'm going to maximize this. That means I take the first derivative with respect to advertising and see what it looks like. Okay, so that's what it looks like. Okay, and I'm going to approximate it with a function of the derivative of profits with respect to C, because the way advertising affects profits is advertising affects C and C affects profits. Okay. And then a function of observables and this unobservable. And the observables, we're just going to play games with the data and see what matters. Okay, I'll show you that. Okay. And then this unobservable, there's going to be one separate one for detailing and a separate one for DTC. And it's going to be allowed to be serially correlated. Okay, so it's mean zero, but it's serially correlated, and it's correlated across advertising. And okay, so I could do this from a more detailed model, but this is enough to get me going. Okay. So notice two things. The impact of others' advertising on my advertising has two roles here. One, it goes through the profit function, because my profit function depends on how much you advertise. Okay. And then the W can also have other functions of your advertising and stuff. And that will be determined empirically. Okay, so now I want to go to the data. I want to show you two properties of the data that make it a little more complicated. Okay. The first property, I need the derivative of profit with respect to C. Okay, I know prices, list prices. They're given to me with the data set. I don't know costs. And in this industry, it's a real problem because costs are net of rebates. So these pharma companies get big rebate, pay big rebates once you buy it, and that's not in the price. Okay. So I'm going to have to estimate the costs along with the other parameters of the model. I'm going to do that in two ways. One, I'm going to use the advertising, the dynamics, the advertising equation to find out what value of the cost maximizes that. Okay. And then I'm going to go back and do what everybody else does, which is the static Nash pricing equilibrium. I'm going to compare them. Okay. The second thing that I told you this before, some of the drugs are advertised and then not advertised and then advertised again. Okay. So if I don't account for the stopping part, I'm going to get a selection issue. So because the guys who do advertise are a selected sample of those who don't, and the selection can be on this unobservable that they're using to predict things. So I need a model for that. Okay. So let me just say the parameter heterogeneity I'm going to use is all the parameters of the investment function other than costs will vary with the two kinds of advertising, okay, with detailing and DTC. And I'm going to estimate separate costs for each molecule, for each drug, okay? And for each drug, and if there's a generic component, a separate cost for them, because generics don't get the rebates that the other kinds do, okay? So before I estimate, let me just, you don't need to know all the equations, but there's an equation for zero advertising, okay? And then there's the equation for positive advertising. And when I look at the equation for zero advertising, I get a functional form for it, which is going to be non-parametric. And then when I look at the equation for advertising, when I do advertise, okay, it's going to be, a serial correlation. There's going to be a rho H in it to get the serial correlation out. And there's going to be an expectation term conditional on doing advertising positive. So that's going to take account of the selection. You have to be a little bit careful because you need instruments here, or you could need instruments. We tested and you did. Okay, so let me, before, the way we do this is we use a nested algorithm. So for each drug, we first of all find the costs that make the first order condition exactly zero. Okay, and so that's one nest. Once I do that, I maximize over the other parameters. Okay, so this is just concentrating out the cost terms. And then after that, I get my residual, and I can use the residual to estimate the two sources of randomness in this. So one source of randomness is the randomness in the fixed cost, and one source of randomness is in the new term where the omega is going over time. Okay. So that's what I'm going to do. I don't expect you to look at this and say, I know, I understand. Just believe me, it's right. Let me tell you what the estimates look like. Here, I'll look at them. These are the cost estimates. For an IO community, this is sort of interesting. So on the left, my left, your right, are the cost estimates from the dynamic advertising equation. And on the right are the cost estimates from a Nash pricing assumption. Okay, a static Nash pricing assumption. Okay. What happens is the margins for the branded drugs are all significantly lower when you do the dynamics. Okay. So the margins for the random drugs go between 86 and 100%. Okay. If you went to the static thing, the highest margin you get is 45% or something on that order. Okay. So, you know, the literature and the industry thinks that the costs are more like 86, the markups are something like 86 to 100%. In fact, most of the papers that have done drugs have assumed the marginal cost was zero. Okay, so so there's something also, the estimates say that the branded have a much higher markup than generic if you do the dynamic one. If you do the static one, the generics have a higher markup than the branded, which is highly unlikely. Okay, so we're going to stick with the dynamic ones. Okay, John, go ahead.
The marginal cost, so this include the cost of advertising. That's not kind of.
No, that's separate. This is the production cost. I should have said that. I'm estimating production costs. Okay. That's the marginal cost. Here's the estimates of the coefficients. Again, I don't think you can read this amount of numbers in 5 seconds. Okay. But so I'm going to summarize. The serial correlation coefficients are all very important. Okay. So the unobserved state variable is very important. The profit derivative is very important. And then 2 other things came out as being very important. One was the time to loss of exclusivity. So, you know, as I approach exclusivity, I do less and less advertising. So that was I approach the end of the patent life, I do less and less advertising. And the other thing that came out significant was the advertising of my neighbors, of the other people competing in my industry, okay, in my market. Okay. So those are the things we're going to keep, and you can see they're highly, you know, most of them are highly significant in most of the thing. Again, 3 stars in Pierre's notation is 0.001 significance. Okay, here's the estimates of the variance terms. 2 things to note: the variance of the fixed cost is about the same. You know, it's on the same order of magnitude as the variance in this unobservable state variable from period to period. And that's true in DCC and detailing, and the same order of magnitude of DCC and detailing, but there's more variance in DTC, and you could have seen that. You'll see that in the numbers. Okay, so direct-to-consumer advertising has more variance, conditional on our state variables, okay, than detailing. Okay, so now I have the estimates. I now have to tell you how to compute equilibria. Okay, so I'm going to take the demand function and costs and the process generating C and the as from the data. Okay, I'm going to use these in an iterative algorithm to compute policy functions that satisfy the condition of experience-based equilibrium. Okay, and then I'm going to do it again for counterfactual institutions. Wow, sorry guys. Both the state variables and the policy functions are continuous. And convergence is going to happen when the policies from adjacent iterations coincide for each period and each drug. Okay. So again, experience-based equilibrium, firms choose policies to maximize the expected discounted value of future net cash flows, conditional on these variables, which are the observables and the unobservables. And then the perceptions are consistent with outcomes at states that are visited repeatedly. So those are going to be the case states I observe. Okay. So I'll give you a brief overview without too much detail. Iterations are indexed by L. I'm going to skip the J index for the drug. Okay. You have initial estimate of the policy function from the data, which I estimated. Okay. Then I'm going to simulate K sample pass. I have the policy function. I know the profit function. I can simulate advertising tomorrow, given advertising today. Okay, and I can do that all over time. Okay, and so I get sample pass for profits and for this omega H. Okay, which is also a markout process. And you got to keep the underlying random draws fixed. Okay, so also on the C process, otherwise it'll never converge. Okay, so just so if you try this, you shouldn't, you know, draw new random draws every time. Nothing will work. That's not stochastic equicontinuity stuff. I then compute the averages. Okay, and you remember that the first order condition from the experience-based equilibria is that the expected derivative of the expected discounted value of net cash flows, which is the number on the left, that sum, which I'm going to do, okay, has got to be approximately the expectation of the individual. Okay, approximately, because I'm not doing infinite sample size. Okay. So you get out of that, you get an estimate of, out of this equation here at the bottom, you get an estimate of the new AL. Okay, this iteration's advertising. Okay. And you get an estimate of the probability that it's 0 and an estimate of positive, it's positive. Okay, and that's these two numbers. Then I got to update the policy function. So how I update the policy function, I take my estimate of the marginal returns, okay, and I regress it and minus the omega term, which he knows, and I regress it down on the same things I did before, on the same things I found in the estimation algorithm and last period's omega. Okay. And then I calculate my criteria function, which is that the expected discounted value of future net cash flows from the two periods are equal. And I normalize by the one before. So you want percentage deviations. It stops if the measure is less than 10 to the minus 5, keeps going if the measure. Let me say, what surprised me about this is it converged between 3 and 6 iterations. It was really quick. Exactly how quick, we're parallelizing, but exactly how quick depends on the, we're doing it twice. Pierre's doing it in Toulouse with Pierre stuff, and then this student of mine who's a superstar from MIT is doing it at ours. She uses these very fast algorithms. So she does it in 25 minutes or 30 minutes for a thing. He does it overnight. Okay, but at least they coincide. So okay. There's how much time do I have?
Still have
okay. Let me just say there's an issue with the terminal period, okay, because I only see data up to some point, but the returns to the advertising at that point are the future, okay? There are two ways to do this. One way is just to simulate out 100 extra periods, or actually we did 400 because it's 100 years, okay? Or you could just, it works out, the paper shows that you can just substitute in the advertising in the last period for the expected discounted value of the future period. This ends up giving you an error, which is the difference between the expectation at the time and the realizations. But that error ends up being mean 0. And you can, so it doesn't really kill you. And so we did it both ways. So let me go to the results. You shouldn't pay attention to the standard errors because they're the first stage variance in the parameter estimate should be going into these standard errors, and they're not right now. Okay, so these are not, they aren't as precise as this says they are. Okay. So the coefficient on the profit derivative is close to 1. We only did 2. We only got 2 done. Okay, where we've matched the 2 things. The others advertising, it's negative. So if you advertise more for the other guys, okay, it has a negative impact on my advertising. Okay, so they would be strategic substitutes. Okay. And also there's strategic complements. You can tell stories each way, but I'll go to it and show you what's going on when I get to the equilibrium calculation. And then the other thing that came out always, didn't matter how we did it. These things come out always, okay? No matter how we did it, was this time to loss of exclusivity. They really do stop doing advertising as they approach the end of patent life. Okay, it's in the data and it comes out of the equilibrium calculation. So I'm going to give you a fit comparison just because there are too many dynamic models where people don't pay attention to that. But I'm not doing it right yet, and I'll tell you why. I wanted to do, what I'm really interested now is computing the 2 equilibria. Okay, so the equilibria with DTC and the equilibria without DTC. Okay, so for that, I don't want to use the X's in the data, okay, or the omegas in the data. Why not? Because I don't have those for the world without DTC. So I want to start them on an equal footing. Okay. On the other hand, if I was just doing fit to the stuff in the data, I'd want to use them. Okay, because I'd want to see, are my perceptions approximately right? Okay, but we just haven't gotten to it yet. Okay, so the other thing you should realize is the data is a random draw, and we're predicting averages. And so I'm going to give you the fit for the non-zero advertising, which in the simulation, what you're doing 100 periods. Is that clear? 100 simulations and then averaging. So there's no, you do get the observations that did stop when you do the simulation. You just average over them. Okay, so you should expect that these numbers, one, aren't as good fitting as they would be when we're finished, but also that the levels of advertising should be a little bit below the actual levels of advertising because I'm taking account of the zeros and I'm only looking at the advertising for the ones that didn't do zero. Okay. So it's hard to evaluate. This is what it looks like for anti-cholesterol. Again, it will get better, but it does have this thing where they're lower than the data. Okay, so on the lower axis is the actual detailing, and on the vertical axis is the prediction. Okay, and it's a little worse for DTC, but it's not bad. Actually, in most, I don't think this is actually terribly bad, but I know it's going to improve dramatically with this stuff. Okay, but at any rate, you can see why I'm doing this. And here, this is for the three biggest drugs in cholesterol. You've heard of them all, right? Lipitor, okay, Crestor, and Zocor. Okay, these are three of the highest selling drugs in the United States. Okay, Lipitor was for a while the top selling drug in the United States. Okay, and you can see the fits, they're not perfect, but they're not supposed to be yet. Okay, but they're reasonably close. Okay, you can see that. Okay, then the thing that we should be we should match pretty well is the simulated net profit, because we're going to do that with the zeros also. Okay, and we still don't have the Xi and the omega right. It's a little bit of an unfair comparison because the revenue is so much bigger than the advertising. So you might expect it to be high, but we saw from this business stealing table, okay, that with large changes in advertising, you get large changes in profits. Okay. What this is showing you is that the difference between the advertising we're predicting and the advertising in the data is small, and the revenue thing dominates. And you can see we're fitting almost exactly. Okay. Okay. So now I'm going to compare equilibrium outcomes when DTC is allowed to equilibrium outcomes when it's not allowed. Okay. And I'm going to compare outcomes to the outcomes when firms stop DTC, alone when their competitors continue. Okay, so this is a business stealing effects. So what we would like to do is in both compare the detailing policy. I'm going to just shut down DTC. Detailing still goes on. Okay. We'd like to compare the detailing policies, the net profits. And again, we will compare consumer surplus. We haven't quite done it yet. It's a little bit complicated, by the way, because everybody has a different price coefficient, right? So you can't just divide by the alpha I. Okay, we just haven't gotten to it yet. Okay. And then I'm going to, we also want to do this tax thing where we tax and then say we're going to advertise from a public fund and not use brand names, but we haven't done that yet either. Okay, this is the simulated detailing with and without DTC. The log detailing is on the right hand, the actual, when we allow DTC is on the bottom axis, and when we don't is on the top axis. You can see they're strongly related. Okay, but they're a little bit different, particularly at the very beginning. There's more there's more detailing than there was when there wasn't DTC, and at the end there's less. What do you mean by the end? The large detailing guys is the end, okay, and the small detailing guys is the start. Okay, so you can see that here. So this just shows that again. So here's what's going on. The small guys are, if anything, increasing their detailing in response to the DTC going down to zero for everybody. Okay, but the large guys are decreasing their detailing. Okay. And there's a single crossing party and it crosses about at the median, a little bit below the median of this thing. So firms that do only a moderate amount of advertising actually increase their detailing when DTC is not allowed. And firms that do a lot of detailing actually decrease their DTC when they're detailing when DTC isn't allowed. Okay, that's what's going on. And this is the effect on net profits. And again, you get the similar thing, which is there's a single crossing property. Again, this time it's a little bit lower than the median. Okay, but the firms who did almost no DTC before actually increase their profits when DTC isn't allowed. And the firms that did a lot of DTC before actually decreased their profits, and by a fair amount, by 50%. Okay, that's a lot of money. Okay, so what's going on here is the firms that did little detailing increase their detailing, okay, but increase their profits even more. Okay, and the firms who did a lot of detailing decrease their detailing, but decrease their profits even more. Okay, so the variance of profits in detailing is going down. It's interesting, the highest 10% of the firms, profits get cut in half. Okay, so this is the comparison of the profit functions. And you can see it goes, it really goes down, and it goes down more for the large guys. Good. I'm going to be, it's always my problem. I'm going to be too quick, actually. So here's one possible explanation. I don't say it is the explanation, but it's one thing that would rationalize this. The data has DTC and detailing highly correlated, also through the derivative profit, but also through the unobservable terms. Okay. So the effect of eliminating DTC on detailing depends on the amount of detailing a firm did. So here's the one explanation. What DTC does, and I've checked this with a doctor, okay, who is the head of Mass General's gastroenterology. DTC influence what the patient asks the doctor for. Okay, these doctors, this guy comes in, he's got 10 minutes. As long as it's in the same ballpark, he says fine. He doesn't want to argue with you. It's got to be on the thing from the hospital, okay, that they let you in, I forget what it's called. But you said that's just fine, okay? So firms who do a lot of DTC, they have an incentive to convince doctors, have an incentive to convince doctors to give their, to tell them that their drug is a good thing, because a bunch of the consumers are going to come in and ask them for that, okay? And as long as they say, it's okay, it's an okay drug, they'll give it to them, okay? Where there's no DTC before, okay, there was less incentive to do detailing for that reason, okay? But now that there's no DTC, now patients don't come in and ask for a drug. They just ask the doctor to give me a drug for GERD, okay? And so that increases the incentives for the smaller guys to do more detailing. That's off the wall. I don't have facts on that, okay? But that's my interpretation. You can also see what happens to net profits over time. And the reason this is happening, you can see the red is the net profits with no DTC. And what's going on here is at the beginning, you get a very steep decline in profits. Towards the end, what's happening is all these drugs are getting off patent. This is an old industry, cholesterol. Okay, so they're going off patent, everybody's stopping the advertising, and the thing wears off, okay, and you get less. So it's in the middle where we lose much profit. Okay. Here's the numbers. So I'm going to focus on the numbers in the subsample that's doing DTC. So the top part is everybody. Okay, the second are the ones that do DTC. And you can see that the mean goes down from, this is logs, but from 7.99 to 7.35. So does the variance go down. Remember, it's log normal, so the variance matters for the average. Okay, and it positively for the average. The net profit goes down from $361 to $171,000 for these. Sorry, this is millions, okay, and this is per quarter. So you would multiply this by a factor of 4 to get annual numbers. Okay, so it goes from and then if you really eliminated. If you look for the business stealing effect, it's much larger even. Okay, it goes from 308 in the data to 54 million per quarter. It's huge. Okay. Okay, so here's what happens when you shut it down. The first, I'm just going to look at the firms that do DTC. Okay, these are the big guys. Okay, by the way, they're the big companies also. They're Merck, Eli Lilly, AbbVie, GlaxoSmithKline that are doing these drugs. These drugs are cholesterol drugs are generating the profits of these firms. Okay, so their expenditures go down by 235 million per quarter. Okay, so that's 800, 900 million a year. Okay, it's a significant amount of money, but their profits go down even more by 109 million. After I take out the detailing and I look at the net profit afterwards, it goes down. And so they've added money because detailing, they're not doing it anymore. Okay, but there's still a net profit loss of $190 million per quarter. So that's about $700 million a year for these firms. That's money even for these firms. Okay, So that's about 53% of their profits. So their profits per year are about $1.5 billion, some number looks like that. And if they didn't do DTC, they would lose 53% of it. Of course, the profit loss, if it was this business stealing thing where I shut me down to keep everybody going, or even larger, they're 83%. Okay. So there is still a business stealing effect, but there is a real effect on the profits of the firms. Okay. So a couple of caveats. We have calculated consumer surplus, but but we haven't integrated out with respect to price coefficient correctly. So I don't want to give you those numbers. The other caveat is there's a loss of consumer surplus does go down, by the way, but I can't tell you how much. Okay. The loss in profits, so the real caveat here is the loss in profits might translate into a loss of R&D, and that might hamper the development of drugs for new diseases. So, I don't want to push it too far, but it looks like DTC is important. That's all, right, at least in anti-cholesterol. That's really all I have now. I'm happy to take questions if I have time to take questions. Go ahead, John.
Well, very interesting, a very cool paper. But I am basically so tired of looking at the Viagra commercials and just wasted space on TV. So I'm not a fan of DDC. And when I think about something like Lipitor, it's generic. I'm saying it should be priced at marginal cost.
Lipitor isn't generic yet.
Huh?
It isn't generic yet.
It's not generic, but they have a generic. It's called atorvastatin, the same molecule, right?
So we have a generic in here for that molecule. So when there's a generic, we have the generic in with the branded alternative. Both of them are separate drugs.
So when they're chemically identical, I'm saying competition should lead profits to be almost zero because that's what we think competition should do. And when you have ETC, you're looking at a distortion. You're seeing massive profits through an artificial raising of messing with demand for consumers. So, and like, what does the average Joe know better about Lipitor is better than atorvastatin when they're chemically identical? So, when you say that I would have thought the consumer surplus goes up a lot. And it really surprises me when you say consumer surplus also goes down. There's nothing in the model to make consumer surplus to go up. The model is, the demand for cholesterol drugs, okay, as a function of price, time, all the, drug characteristics and stuff like that. And one of the characteristics is generic. Okay, but that's it. Price falling, doesn't that cause the consumer surplus to go up? We have the actual prices. I know the prices, they're in there. The actual prices that are done, they're in there. And I would expect that prices go down when you eliminate ECC, don't they? They don't go down? Oh, no, that we don't have in the model right now. Prices are set in these things for long-term contracts. I doubt that but I don't know. I mean, that's true. We don't have that in the model. Prices don't go down. I think that's critical. I mean, what do you expect is you cut down advertising, price is going to go to marginal cost. Consumer surplus. Why? It won't go to marginal costs. Well, I mean, I can tell you it won't do it. I mean, I've seen the data. Okay. Well, yeah, let me just say, when I started this, I had your impression. Okay. I expected, that's the reason we took the project. I expected the DTC was just a moving of profits around between different firms. Okay. But in fact, it actually is what the industry is saying. There's some truth. And you got to understand that the people who are doing it, so who are they directing this to, right? They're directing this to people who don't go see doctors and get ill. Okay, that's who watches TV and finds out about it that wouldn't find out about it from his doctor. So there's an inequality argument here that they make very strongly. They say, look, it's not true. I'm thinking about ulcers was the one I heard. Yeah, the answer is you don't allow us to do DTC. All these people in poor neighborhoods that eat very rich foods get GERD, heartburn, okay? They don't know that they can solve the heartburn problem. By the time they go to the doctor, they have ulcers. Ulcers is a very serious disease, okay? That's their argument, okay? Whether it's right or wrong, okay, I don't know, okay? But I can tell you what the data says about anti-cholesterol. If I think you have to get prices in there, you have to endogenize prices. How am I going to endogenize prices? I told you that the static pricing thing doesn't work at all. Yeah. It's crazy. Yeah. I mean, so, I have to, we can try doing endogenous prices, but I actually don't think it will change things. But
That's fine.
I mean, the fact, just one more point, pharmaceutical companies have a big role, you know, when I go there, I'm taking a torvastatin. The doctor prescribed Lipitor, my pharmacist said, no, we'll give you a torvastatin, it's a lot cheaper, same molecule, so I take it, right?
So let me show you, John, let me see it.
Let me. A lot of money.
Let me say, so you can see what happens towards the end of the patent life. The profits are actually going down at the end of the profit life, just like you say. That's when your generic comes in at the end of the sample.
Yeah.
And it's true, profits go down then, okay? But to saying that, you know, DTC has no effect on people, I think that's just, I mean, the estimates say that's just wrong. And I think the industry was right about that. And by the way, I started out being what you just said. I've just looked at them. They may be wrong for other markets. We're going to do all 4 markets eventually. I'm not saying it's true for all.
Well, you're not the Eli Lilly professor of economics, right?
No, honest, I forget, Thomas professor, whoever Thomas was, he's my guy, and I never met him, honest. Anybody else? Go ahead, Ashley.
Start changing. It seems to me like the result I was thinking at the end was there's the total quantity of prescriptions, right? Like, these are the number of patients who are going untreated.
Yeah, we do that.
Okay.
So what's happening, here's what we do for that. I mean, the size of the market that we're doing, we're getting the number of people with cholesterol disease from the NIH, okay, from the National Institute of Health. We're plugging that in at just an exogenous factor. Okay, so when this goes down, consumer surplus, that's the reason it goes down. Okay, in the early periods, people who, you know, just
Less about all of that than just literally saying we're
oh, we'll give you that. That's fine. That's a good. I will do that. Okay, we just, you know, we were rushing just to get this done. Actually, as I got on the plane, I got the last numbers from Pierre, and I fixed it up when I got here. Anybody else? Go ahead.
It seems like when eliminating DTC is changing technologies from one where quality like marginal cost, one where quality has a high marginal cost. The detailing is a high marginal cost or per prescription.
They're both
each doctor.
So they're both in dollars. DTC and detailing are in dollars.
That's right. That's not saying marginal cost as opposed to the last pill.
So we got to be a little bit careful. Let me be a little bit careful. So I never used the right word. I should have said production marginal cost when I said marginal cost.
I agree with that. No,
okay.
I think about the Shackett and Sutton stuff, which says that if the investments in quality, the cost of quality has little marginal cost in pill, we're going to end up in a very concentrated market. And if quality has a high marginal cost, we can end up with very unconcentrated. So I wonder if we're switching between those two technologies in an interesting way.
Well, one thing is true. The quality does, the advertising does in fact quality, and the quality is just the demand system. I'm getting it by inverting the demand system. So it's very clear that that's true. Okay. And the quality is being built up over time because these C's are serially correlated. So in that sense, it's like Sutton. I mean, I always thought Sutton was too simple to use literally. I mean, it had, yeah, but in that sense, you're right. It is like Sutton. Anybody else?
Time for one more question.
Go ahead. Can you, yes, it does.
And so I'm just thinking of the way you model it, you see it depending on our pricing. That's one story. Another alternative story is the consumer advertising does change to attention. And it may not affect C, but
I think that's what's happening. So again, I think my interpretation, what this gastroenterologist told me, okay, is people come in, they have, he was an ulcer guy, okay, they have ulcers. They're going to ask for Zantac or something, they have GERD, okay. Yeah, and the doctor said, he says, look, Zantac is on my formulary. I can give him Zantac. Why should I argue about Axid? Do you know, it's the same stuff essentially. If they have the same probability, I'm just going to give him Zantac and get him out of my office. Okay, and so that, in a sense, that's what you're saying. But you're saying, look, these people who didn't know that they could get a pill to solve GERD, to heartburn, okay? They didn't know until they saw the TV commercial. The TV commercial was for Zantac, okay? They come in and they say, look, I need Zantac because I have heartburn, okay? And that's enough for the doctor. He just doesn't want to deal with it any further than that. It doesn't make any difference to him giving him Zantac or Axid. You know, so it's a little bit your story. That's my interpretation of what's going on. I could be wrong, by the way.
But that just smells to me of artificial product different, same molecule, one's called Zantac. You're calling that that's a better product because it's called Zantac?
It's because people who go, what's good about it is the people who go see the doctor that wouldn't have gone to see the doctor before. That's what's good about it.
Well,
And that saves ulcer. But, you know, if you
the
look,
doctor says, listen, instead of getting me out of the office, listen, I'm going to give you a generic.
That's not the way they work.
A lot of money.
there are two issues too. First of all, the issue is going to the doctor. Okay. And then the second issue is, what does the doctor do? Okay. So going to the doctor is the big thing where there's consumer surplus generated. Okay. You can see that when you're, whatever the name of your generic is, okay, when it comes in, you know, when the things go off patent, it all goes away. Okay, that's true. Okay, but in the interim, there were a lot more people who went to see the doctor because they saw it on TV. And if you were in Boston, they'd be coming from Roxbury. Okay.